Have you ever just watched a baby and wondered, what is going on in there? How does that little person, taking in a world of blurry sights and sounds, eventually become an adult who can, do taxes or debate philosophy? Well, today, we're going on a tour of one of the most incredible journeys there is, how the human mind learns to think.
So let's get right to it. This is the big question, the one that's kept psychologists busy for more than 100 years. How does that jumble of thoughts in a baby's head somehow organize itself into the structured, logical, complex mind of an adult? It's a massive puzzle, and the pieces are absolutely fascinating.
All right, so here's our game plan for the tour. We've got 4 main stops. First, we'll meet the 2 giants who pretty much built this whole field. Then, we'll check out a new idea, thinking of the mind as a kind of machine. After that, we'll see how modern scientists started poking holes in those early ideas. And finally, we'll put it all together into our very own cognitive toolkit.
And our journey starts with them, the 2 thinkers whose ideas really laid the foundation for everything we're going to talk about today, Jean Piaget and Lev Vygotsky. Honestly, their competing visions still frame the entire debate.
And you can really boil their whole debate down to this. In one corner, you have Piaget, who saw a child as a little lone scientist, tinkering and experimenting to figure out the world all by themselves. But in the other corner, you have Vygotsky, who saw a child as a social apprentice, learning by doing things with people who know more. So is learning an inside-out job or an outside-in one?
Let's dig into Piaget's view first. For him, kids aren't just empty buckets that we pour knowledge into. No way. He said they are active builders, literally constructing their understanding of reality piece by piece. And he believed this construction project happens in a series of very clear, predictable stages.
Okay, so first, babies are in the sensory motor stage. The huge cognitive leap here is something called object permanence, the amazing discovery that when you hide a toy, it hasn't just blinked out of existence. That's the start of a stable mental world. Next is the pre-operational stage, where a toddler's thinking is egocentric. And this is key. It means they literally cannot see the world from someone else's point of view. It's a cognitive feature, not a moral failing. Then, the concrete operational stage brings a huge upgrade to logic. A child finally gets conservation. They understand that the amount of juice is the same whether it's in a short, wide glass or a tall, skinny one. Logic wins. And finally, we hit the formal operational stage, which unlocks abstract reasoning. Now you can think about things like justice, morality, and complex what-if scenarios. But then Vygotsky comes along and offers a completely different way of looking at it. He argued that you can't possibly understand a child's mind without understanding the culture and the people surrounding it. For him, thinking wasn't some solo journey. It was a social inheritance, passed down through language, collaboration, and everyday interaction.
Vygotsky's most powerful idea, hands down, is the zone of proximal development, or ZPD. Just think about learning to ride a bike. There's what you can do all by yourself, which is probably just wobble and fall over. Then there's what you can do when a parent is holding the seat and running alongside you. That little gap, that magic space where learning happens with just the right amount of help, that is the ZPD. It's where teaching and guidance make all the difference.
All right, so after those foundational thinkers, the field got a kind of tech-inspired makeover. A new wave of theories popped up, and they all shared a powerful new metaphor. They started thinking about the mind as a kind of machine. And the most popular machine metaphor by far was the computer. Information processing theory basically sees our mind as a biological computer. It takes in information, that's the input, it messes with it, stores it, and then pulls it up later. So from this point of view, getting smarter is really just about upgrading your hardware and software. You get faster processing speeds and better problem-solving programs as you grow up. So how does this mental computer work? Well, information first hits our sensory memory, but it only lasts for a split second. If we decide to pay attention, that info gets promoted to our short-term memory, or what we often call working memory. Think of this like your brain's countertop. You can only juggle about 7 things on it at once. But if you work with that information, you can encode it into the giant, seemingly endless library of your long-term memory. But not everyone loved that computer analogy. Some felt it was too neat, too linear. So they proposed a different kind of machine, not a computer, but the brain itself. Connectionism says our thinking works more like a massive, interconnected web of neurons, all firing together. And here's the really cool part. In these connectionist models, a memory or a concept isn't stored in one spot. It exists in the strength of the connections between thousands and thousands of simple little nodes. So when the network sees lots of examples, like pictures of different cats, it slowly strengthens the connections that help it recognize catness. Learning isn't about saving a file. It's about the slow, gradual tuning of this massive web based on experience.
So let's fast forward a bit. We're now in the modern era, where scientists started to look back at these classic ideas and say, is that the whole story? They began to challenge and refine things, adding new layers of complexity to how we think about, well, thinking.
So you've got thinkers like Jerome Bruner, who suggested that we learn and store knowledge in 3 different ways. First, as babies, it's all inactive. We learn by doing, by physically interacting with things. Then comes the iconic mode, where we can think in mental images. And finally, we achieve the symbolic mode, where we can use abstract things like language and numbers. This led him to a really cool idea for education, the spiral curriculum, where you keep revisiting topics, but each time at a deeper, more symbolic level.
And this brings up a really important question, one that kind of bugs me about all these stage theories. Does our thinking really develop like climbing a neat staircase where you leave each step behind for the next? Or is it actually a lot messier than that?
This is where Robert Siegler's overlapping waves theory comes in and just makes so much intuitive sense. He said that at any age, a kid has a bunch of different strategies they can use to solve a problem. Think about a child doing a simple math problem. They might count on their fingers, or maybe they count out loud, or maybe they just remember the answer. Siegler said development isn't about jumping from one stage to another. It's about these waves of different strategies rising and falling in popularity as the child figures out what works best. It's so much more fluid and, frankly, more realistic.
Okay, and for our last big challenge, let's go all the way back to the beginning. Are babies really born as blank slates, like people used to think? Well, core knowledge theories argue absolutely not. They suggest that evolution has given us a head start with some innate starter kits, basic, built-in systems for understanding the really important stuff.
So what's in these starter kits? It seems infants come preloaded with a basic grasp of physics, like they know objects are solid and don't just disappear. They have a gut sense for numbers, being able to tell 2 things from 3 things long before they can count. And maybe the most important one, they seem to get that other people have intentions and goals. This isn't stuff they learn from zero. It's the pre-installed scaffolding that all other learning gets built on.
Okay, so we've been on quite a tour, looking at all these different, sometimes competing ideas. Where does that leave us? Well, the best way to think about it is that we've just collected a really powerful set of tools. No single theory is the right one. Instead, each one gives us a useful new tool for understanding the mind. Just look at how they all give us something different. Piaget gives us that universal stage-like map of how logic develops. Vygotsky reminds us that, hey, none of this happens in a vacuum. It's all social. Information processing gives us the nuts and bolts of memory. Siegler shows us the messy, adaptive reality of learning. And core knowledge reminds us it all starts with a foundation that was built by evolution.
And that really is the big takeaway here. None of these theories is the complete picture. But when you put all of these lenses together, when you see a child as a scientist, an apprentice, a computer, and an evolving creature all at the same time, that's when you start to get a truly rich and much more accurate picture of how a mind actually grows.
And what really unites all of them is this central idea from our source material. They all highlight the active, internal mental work a child is doing to build their own reality. Development isn't something that just happens to them, it's something they do.
So I'll leave you with this final thought to chew on. Our world is changing faster than ever before. The cognitive demands are totally different than they were 50 years ago or even 10 years ago. So, thinking about everything we've talked about, what new skills, what new ways of thinking will be the most critical for the next generation to thrive in the world of tomorrow?